Hey everybody, and welcome back to another video in this series. In the last video that I made, we ended up looking at how to put together our gait functionality within our update movement function, so that way when we do certain things with like stick deflection or movement, that we get our desired gaits, especially with like the booleans of like wanting to sprint and wanting to walk, etc. You know, that stuff. One of the things that I did forget to do in the previous video, because we did set up another input action for world space, I did forget to modify that for us to show you what values that they use in the game animation sample project, or at least set them up appropriately for us in here within our own project from scratch, right? So that is something we're going to do real quick. And also too, I forgot to update the UI as well. So in saying that, what we're going to do is we're going to quickly put together our world space mappings and whatnot that they have in the game animation sample project. So we're going to hop quickly into third person input IMC mappings, and we need to add our, let's see, our world space, right? So we need to add 4 buttons, and what they utilize in the game animation sample project is the up button, the down button, the left button, and the right button. And what they also have set is they have modifiers set accordingly, just how they have the IA move. So what we want to do real quick is for our up button is add the swizzle input access. For the down button, we want to add 2. We want to add the swizzle input access, and we want to add the negate modifier. Then for our left, we want to add negate, and then for our right, we want to add nothing. So similar to how we have the move set up, right? So, you know, how we have our modifiers here, just to match them, but that's how you're going to set up the world space. So I did forget how to do that in last video. So I'm going to go ahead and save once we do that, and then let's go ahead and hop into our widget if you still have that open. And what we need to do in here is we then need to add our gait, because I did forget to add that. So we're gonna add 2 text blocks in here. Did I add it? Where is this? No, so I forgot, I didn't attach it. So let's go ahead and move those. So our is aiming is at a Y position of 120. So let's go ahead and make this 150 and then give it a padding of 20. And then for our, let me see, our text block, let's call this, actually before we do that, let's call it our gait, because that's kind of how we have it tied to our enumeration file that we made earlier, or at least in one of our previous videos, or at least last video. So we're going to call it gait, just like that. And then let's move the other one down. I called it 150. Yeah, so 150 on our Y for the second text block. And then 50, no, 80, nope, 100. All right, cool. 100 is a good fit for it. So now what we want to do is we want to go ahead and on our second text block, hit bind and create binding. And in here, let's go ahead and grab our character reference. Oop, didn't mean to hit that. Let's grab our character reference and get our gait. So just like that. So that way we call our gait enumeration that we have set up in our character blueprint. And then what we're going to do is we're going to grab a select node, if I can spell, a select node, and we are going to connect our gait into the index. That way we can get our walk, run, sprint. And then for here, let's go ahead and create 3 local variables, just kind of how we've been doing in the other mentions of UI, right? So let's go ahead and change these all to text. And let's call this walk, and then put it for the value in here. So walking. And then our next one is going to be run, and we'll call that default value running. And our last one is our sprint, and I'm going to call that sprinting. So let's go ahead and drag all those out into our blueprint and then connect them accordingly. So our walk to our walk, our run to our run, and our sprint to our sprint, just like that. And now let's go, let's go ahead and connect that into the return node and compile, save. And so if we hit play, we should now see our gait where we have walking and we should have running. If I hit shift, it's not changing yet. Is the functionality messed up? Real quick, guys, I'll be right back. All right, guys, I'm back. I greatly apologize for that. I always seem to have issues making sure that everything's in proper order before telling y'all what to do. So I did figure out what the issue was. We do need to go back into our third-person character blueprint and attach our update movement function to our event tick, so that way we get the proper updated gait for our movement. And also another thing too is once you do that, once you attach update movement to your event tick, go back into your game HUD and actually get rid of that select node. There was a much easier way that I did this, where I instead did a, get character reference and then get gait, and then we drag off of gait and do an enum to string. So that way it makes the enums, like each selection or whatever our gait is, into a string, and then we convert that string into a text as we pass it in here. So that's what you're going to want to do. So just to show you, we drag off the gait and do an enum to string, just like that. And then we can just connect the string into the return node to get the text from string node. So once you do that and you compile and save, then when you play, you'll see that we're in a run gait, because that's kind of where the start is for it. And then if we hit shift, it's going to change to sprint. And then if we hit our walk button, it'll change to walk. So we got that, and we can see now that get desired gait works for our UI debugging. So now that we've gotten that, we're going to work on the next part of this video, where we are going to then calculate the max move speed. So that way when we go walk or we sprint or we run, we get the correct speed for that movement, right? So let's go ahead and hop into our update movement. And what we're going to do is we're going to create a new function over here on the left called calculate max speed. Right, yeah. Now, once you do that, what we're first going to start with is we need to calculate the direction first. And there's a reason for that, because eventually we're going to be making a curve float and getting certain values. So we're going to drag our character movement, and we're going to then drag off to get our velocity. So once you do that, scroll all the way down and grab your velocity. We don't need to do any sets or anything like this, but we need to get our velocity, because this is one of the things that we need to calculate our direction. So you're then going to drag off of velocity, and you're going to do calculate direction. So see how you have to connect the velocity into that. So if you remember what I mentioned in a previous video, or if I did mention it at all, velocity is essentially your speed in a certain direction. So basically, if I said I'm moving 50 miles per hour north or west or east or south, that is my velocity. I am moving 50 miles per hour northward or 50 miles per hour westward. That is your velocity, is where you're going in a direction with a certain speed. So in saying that, now we have to get the base rotation. So what we're going to do is we're going to right click and we're going to do get actor rotation. So that way we can get our actor's rotation, and we're going to connect it as such into here. So basically when we do this, and I'll show you just briefly, so I'm going to promote this to a variable and I'm going to call it direction. And you don't have to copy this, just follow along. And so if I do this, and let me go to the event graph, and I'm going to do stats for debugging and add a pin here. So if I call direction, not set direction, I'm going to get the direction. Get direction, why is it not popping up? So let me do this instead. I'm going to grab this, and I'm going to set it in our update for stats as such, like this. So let's go ahead and do that, and we're going to then print string, and I'm just going to do this for a temporary measure because I'm just going to delete it. And then when we look at it, as you can see in the left side, all the zeros that are pouring down. So as you can see that as I move around, so if I go forward, I'm getting zeros. As soon as I move, it changes the rotation or getting the direction of our character. So if I do orient, rotation, and movement and start moving around, you can see how the sudden changes it's making. Or if I strafe and I go right, you get a 90. If I go left, you get a negative 90. If I go backward, you're gonna get 180 negative. So that's pretty much what it's doing there. And there's a reason why we're getting that, or we're trying to get that, because with our curve float, we're gonna need those directional pieces. So let me hop back in here and I'm going to delete that, get rid of that, and I'm going to put my comment from my actual project into here, just so that way in case y'all want to copy it down so you know what's going on. That's perfectly fine. Then what we're going to do is we're going to then drag off of the return value and get an absolute float. So basically what this node does, in case you're not familiar with how absolutes work in math, is what an absolute does is it essentially always returns a positive value of the number. So if, say I have a negative 90, but I put it through an absolute transformation, we're just going to get positive 90 regardless. So if I were to do this and set it now, our direction will always be at a positive. So if I went like I showed you with what I just did, we got a 0 going forward, we got a negative 90 going left, a positive 90 going right, and a negative 180 going backwards. So what an absolute will do is the negative 90 to our left will then be a positive 90. Our going backwards, getting negative 180, will then turn into 180. So that's what's going on there. So once we do that, we now need to off of here, or not off of here, but get float value. Oh wait, we can't do that yet because we do have to do something. So for the moment, compile and save and go back to your third person map. And what we're going to do is we're going to hop into our third person blueprints data folder, and we now need to make a curve float map. So what we're going to do is we're going to right click, and we should be able to do curve, type in curve in the search, and there we go. It's right here. What we need is this one right here, or it just says curve. And then once you do that, the classes you're going to choose from, we need this curve float. Once you do that, you're going to hit select, and then we're going to call it curve underscore strafe speed map, just like that. So the whole point of this map, so let's go ahead and open it up, double click it, and let's dock it here. So what we're trying to do is, and I'm going to show you, so let me put up my other project, is we are trying to get this float value, because what we want to do is, using the curve float from the strafe map curve, we want to attempt to retrieve the float value. So we do this by doing a get float value and connecting the return value from our absolute direction calculation. So in your float curve data, what we need to have the following points marked, which are 0, 0, 30, 0, 81, 101, 152, 182. And I know I said that kind of like that, but I'm talking about points 100 and then point 1, etc., like that. So what's going on is when walking or running forward or left, right, whatever, or let's just do forward for example, the calculate direction node will return a value of 0. When strafing left, right, the calculate direction node will then return the value of negative 90, 90. However, the absolute makes it always 90. When walking strafing backwards, the calculate direction node will return a value of negative 180, but the absolute makes it always 180 positive. So by using the direction value that we get from here, what we're trying to do is get the value that we set on here. So between these points, and these points, we're trying to get these 0, 1, and 2. So that way we can indicate that if we have a 0, we're going forward, 1, we are strafing left, right, and 2, we're going backwards, and we're going to pass those into our strafe speed map. So going back into it, So like I said, so what we're going to do is in the strafe map, we're going to right click and we're going to add a key. So our key, so if you click on it and you go up to the top, we need to make it 0 and 0. So here it is right here. Then we need to add another key float. And this time we're going to make it 30 and then 0. And if you ever want to see how this looks, what we can do is, where is it? Snap, it's not that. So we need to do zoom to fit, here we go. That way we can find our values. So, actually we're gonna need to zoom out a little bit. Because we have 30, 0 here. Where is our 0, 0? Oh. I know what's going on, I gotta zoom out a little bit more because I didn't do it. So here we go. So now you can see that we have 2 points. We have our 0, 0 and we have our 30, 0. The next one we need to create is another key, and this time we got to give it 80 and then 1. And then after that, we are going to add a 100 and a 1. And we're going to straighten this up in a minute, but for the moment, just kind of copy it as such, and I will go over the explanation. So then we're going to add another key. We're going to call it 150 and 2. And then we're going to add one final key, and we're going to call it 180 and 2. So now what we can do is, once we got those points, we can highlight all these points and go back up to this button right here, zoom to fit. So that way we get a zoom to fit chart as such. So now you can see the points much better, right? So what we're doing is essentially, as you can see if I hover over these points, right, that we have a time of, 0 or 30 or 80, 100, 150, and 180. Then we have values of 0, 0, 1, 1, 2, 2. So basically what we're trying to get are those values, and we do that by getting the time using the direction of our character. So like I was showing you in here, what we're doing is we're trying to calculate our direction, which is negative 180 to positive 180, but we're converting it into a positive value using absolute, so we always get 180 or just always positive numbers. Then we're trying to retrieve the float value off of our strafe speed map curve by using the direction as our time to then get the value of 0, 1, and 2. So, and I'm going to show you this. So once we have that, let's go ahead and save it. Save it. There we go. And then pop back into our third person character. And then we are going to then create a variable. I believe it is, yeah, it's going to be a normal variable. And we're going to call it strafe speed map curve. I like how that didn't type at all. There we go. Strafe speed map curve. And what we're going to do is we're going to then grab our curve float. Could be, where is it? Hang on, straight. Oh yeah, we need to do, I'm sorry about that. So we do need to do a curve float, and we do need to do an object reference. Then we need to compile and save. And once you do that, then the default value will appear. That'll allow us to then get our strafe speed map curve like that. So make sure you put that variable in and then grab the curve float, compile and save, and then grab your strafe speed map. Once you do that, go ahead and compile and save, and then we need to get our strafe speed map curve and put it in the blueprint, and then drag off and grab the get float value like that. Then from your absolute float, go ahead and connect it to the end time. So to go over it again, we need to grab our direction that we're going in, convert it to always positive numbers, and then pass it to get the float value. So when we do that, so like I mentioned earlier, when we move forward, our direction is 0. So we'll be getting these values right here. So from 0 to 30, because there, as you saw when I moved around a little bit, there was a little bit of a nuance or like margin of error to the direction. So up to from 0 to 30, we will grab our 0 value and pass that through. When we go left right, as you saw, they were negative and positive 90, but now they're always going to be 90. So with a little bit of variance between 80 to 100, we are going to grab the 1 value when we move left and right. Then when we move backward, because there's a little bit of a variance there as far as value, it's going to be, 180 going backwards. So from 150 to 180, we will be grabbing the 2 value and passing that through. So let me go ahead and copy these notes into here for y'all to jot down y'all want. Just like so. And then let me grab the big chungus note and I will put it here. So like I said, guys, at any point in time, you're more than welcome to pause the video and grab these notes if you do need them, just so that way you know what's going on within the project. All right, and then now what we're going to do is off of our get float value, we are going to promote to variable and call it our strafe speed map. Just like that. So then once we have that, we can go ahead and connect our calculate max speed input function, or the input of our function, to that. So that way we have that. So now, just so that way you can see what's going on, I'm going to then go into our game HUD and I'm going to add more text nodes. So let's go ahead and grab 2 text nodes or text blocks. And this time I believe the Y is going to be 180. Yep. And 20. And let's call this our strafe speed map. Yep. Get spaces. And then we get our second text block and make that 180. And then I believe 200, 280, 300. Let's see. Yep, 300 is good. And then click on it and we're going to bind it to a function. And we are going to grab our character reference and then our strafe speed map right here. We're going to get the float, not the curve. And then we are going to pass it by converting it from a float to a text. So now, like I said, when we go forward, we should have a 0. When we go left, right, we should have a 1. And when we go backward, we should have a 2. So as I'm going forward, we have a 0 and it's not updating. So why is it not updating? Oh, I know why. It's because we don't have it set yet in our calculate max speed. So if you go back to your movement function and let's go ahead and do our calculate max speed for the moment and pass it through that, then we'll be able to get it. So let's go ahead and do that. Save. And there you go. So from left to right, we're getting 1s. When we move backward, 2. When we move forward, 0. So just like that. So now let's move on to the next part. So this one is going to be a pretty long one just because of how we're going to explain it, but it should be a lot simpler, right? So let me pull up the game animation sample project so you can see what we're going to be doing, right? So in here, if we go to our, got a lot of stuff open. So let's go to our blueprints, character, and then I'm going to go to the update movement, calculate max speed. I changed it in here, but basically they had a bunch of vector values for movement, like you see here, walk speed, run speed, sprint speed, crouch speed, etc., to do the different things. And I'm going to change a couple other stuff up, but I felt like this was a bit simpler to do it like this by making a structure of relevant content. So that way we can get the speeds that way and it's much easier to maintain. So that way if we do other speeds in the future, you could just tack onto that and then pass it through here to get what you want. So what we're going to do then is let's go ahead and we're going to open up our third person map and we're going to come into our data folder and we're going to create a structure. So you're going to right click, go to blueprint and then structure, and we're going to call it S gait speeds. just like that. And once you have that, go ahead and open it up, and let's dock that. So what we're going to do here is, like I showed you in the game animation sample project, is we're going to then get our gait speeds now. So we're going to create 4 of them at the moment, or no, we're going to go ahead and create all 5 just because I want to show you something pretty cool. So we're going to then add 5 variables. So we should be able to have our walk, run, sprint, crouch, and I'm going to add the aim speed because I like it when my character slows down when aiming, and it's more realistic. So let's go ahead and change these all to vectors real quick. And then once you do that, let's go ahead and go through it and call them walk speeds. And there is a reason why I'm calling them speeds, like with an S, and I'll show you in just a second. Run speeds. Oh, come on. Sprint speeds. Crouch speeds. And aim speeds. Just like that. So now let's go ahead and head into the default values and take a look at this, right? So basically what we're trying to do here when we do our project, so let me open back up the game animation sample project for you to see. So what we're trying to do is we're trying to get vector ranges, and basically what's going to happen is when you move forward, and that's why we have the strafe mapping here. So in your forward motion, you are going to get the X value of the vector for your maximum speed going forward. You're then going to do your Y speeds to do your, your Y speed of the vector and pass it through here for the strafe map. And then your Z speed is then going to be your backwards or your outrange. And I'll explain that in just a moment because you're going to see how it works. So that's what we're doing, is we're modifying the different speeds. So that way it's realistic when you're walking forward or going left, right, or going backward. So let's go ahead and go back to our project and make these speeds. So as they have it in the game animation sample project, which I do like, is for the walk X speed, we have 200. For the Y speed, they have 175. And for the Z speed, they have 150. For the X speed of the run, they have 500. For the sides, they have 350. And for the backwards, they have 300. For the sprint, they had all 700, but I don't like that. Because if you're trying to sprint left and right there and go sprint backward, you're going to be slower, like a lot slower. So I ended up doing 650 and 600 as I found those comfortable values for me. And then what I did for the crouch and the aim speed is I pretty much just copied the walk speed. So we're 200, 175, 150, 200, 175, 150, just like that. So now we have our different speed set. So like I said, when we move forward, we're going to end up getting the X values as our maximum speeds. When we move left or right, we're going to get these as our maximum speeds. And when we move backward, we're going to get these as our maximum speeds. So let's go ahead and save that and hop back into our third person character. So now what we need to do is we need to go ahead and create, I believe it's a local variable. No, it is not. It is a normal variable, and it is going to be under movement. So I'm going to extend our movement, and let me put our strafe speed and our movement in there. And I'm going to create a gait speed. Since we already have gaits, we can't use gait, but I'm going to use gait speeds because we're getting our gait speeds. And then in here, we want to do S gait speeds as such. And then move it into your movement grouping. And then let's go ahead and get it and drag it out. And let's go ahead and compile and save. So now we need to split these struct pins. So now what you will see, or should see when you do that, is you have your different speeds. So now when we open it up on the details panel, you could see that our speeds from our structure value file is there. So that is good that we see that. Let's go ahead and move it over. And what we want to do now is grab a select node because we want to now do our various checks to ensure that we get the proper speeds. So the first thing that we need to check is our gait. So go ahead and grab your gait from the left variables tab and pass it through the index. So now that we should see our walk, run, sprint speed, or our sprint selection. So go ahead and connect your walk to your walk, your run to your run, and your sprint to your sprint, just like so. Then what we want to do is we want to create another selection process. So go ahead and get another select node. And this time we want to get our is crouching functionality. So you can do this either way, but I'm going to follow how they did it. So in our inputs, or not our inputs, but your character has like an is crouched functionality, right? To get is crouched, and if so, do X, do Y. But the way that they are doing it, because it's a built-in function and detects it a lot better, is they're using the built-in is crouching to detect whether you are crouching or not. So we're going to get this, and we're going to pass the boolean into our index, that way we can get true or false, and then be able to make our appropriate selections. So what we want to do is now we want to check if we're crouching. If we are not crouching, then we want to be able to get the corresponding speeds from the first select node and pass them in through here. If we are crouching, then from our crouch speeds, we want to then put that in the true to get our corresponding crouch speeds. Let me go ahead and make it look pretty, just like that. Okay, now, or actually let me do this. So now that we are good to go on that. However, like I said, I added an aim speed. They do not have that in the game animation sample project. I've added this personally because I like the functionality of this and I wanted to see it implemented. But before we do that, let me show you what they did before we add my aim speeds. So from your select node, what they did is they split these struct pins, because again, we're trying to get the X, the Y, and the Z speeds at like so, right? So we're splitting it in order to get those corresponding speeds. So let's go ahead and then get our strafe speed map and place it out here for the moment. And what we want to do is do a map range clamp. So what this does, these map range clamps, and that's why we set our curve float map to a float map, is because we're trying to get the values that we made in here and pass them into those range clamps. So when we're going forward, we get a 0. If we go left and get a 1, or right and we get a 1, or we go backward and get a 2, we're trying to then clamp those into here, so that way we get the correct appropriate speed for our movement. So we want to get the float value from our strafe speed map, like how we set earlier, and pass them into our float, or our values for both clamps. Then if we are in range 0 to 1, we are then going to get certain values. So if we're in range A, so our 0, or our speed map of 0, we want to get the X speed of our walk, run, sprint, crouch, aim. So here, what we're saying is, as long as we're in 0A range, we are going to get speed 200 if we're walking, 500 if we're running, 700 if we're sprinting, etc. And then we're going to return this out range as our value. Then we're going to get our Y, and we're going to do it in the B here and the B and the A here. So the reason we're doing this, and let's go ahead and set our second clamp range. So we need to have an in range of 1 here and a 2 of here. So what we're essentially saying here, or what we're doing here, is to get our Y, if we are moving left and right here, we want to be able to retrieve our 1 value and then get the appropriate Y speed for our walk, run, sprint, etc. So our 175, our 350, our 650, etc. And then lastly, we have our Z, which we're going to put into here. So that way, if we're in range of B, so our 2, so if we're moving backward, then we are going to get our backwards Z motion, which is our 150, 300, 600, etc. So that's what's going on there. So now what we'll be doing is we're going to then get a select float node as such, and we're going to pass in this as our A value to get the corresponding range from either the X or the Y, and a return or in our B into this clamp to get our Y and Z if we're in these ranges, right? So we also need to grab our strafe speed here and copy paste it here. We're going to drag off and get a less than node and put it into our Boolean selection, and we're going to put a 1 here. So if our strafe map speed value is less than 1, we're going to do A. So then we'll be doing these options. If it's not less than 1, so if it's 1 or 2, then we're going to do the second range clamp functionality. So that's how we basically get our speeds for the different direction. And then once you do that, we're going to then do a return node, or let me go ahead and right click and grab a return node, and we're going to return our value here. And then once you do that, let's go ahead and zoom out and connect our strafe speed map into the return node just like that. So that is how they have it set up, except they used vectors over here. I used a structure file just to keep all speeds together, but that's how you're going to do it. So that's how you essentially get the different speeds. If it is a bit confusing, I do apologize. I try to explain it the best I can. But as we go, if you need to go, you can definitely rewatch this to try it again. But again, what I am going to do is let me go ahead and get my comments over here so y'all can copy and paste them to have them as reference just in case. So go ahead and pause the video if you need to, just to get that. I changed the group. And then let me grab the other node, put it here. All right, and then let me grab the crouching one, and this one I am going to have to change up a little bit. Actually, guys, my apologies. I just realized that I messed up something real quick. What we need to do is we need to adjust this ever so slightly, because I did get a little bit ahead of myself. So we need to actually get rid of these pins and recombine these, because as I'm looking at my other project, they had a third select node for this. So I apologize for that, guys. Or actually, no, I had the third select node. Never mind. But let's go ahead and add it anyway, since we're on the topic. So if y'all want the aiming speed as such, and this was my fault because I was looking at my other project and was like, why is there something there? So if you want to get the aim speed, so, you know, to match the walk speed and whatnot that we set in here. So basically the same thing we did with it is crouching. We're going to go ahead and from our input, we're going to get the wants to aim node just like that and attach it to the index. And then we are going to return this value into false, because if we are true, then we want to get the aiming speed that we set in our gait, or our gait speeds. So go ahead and grab the aim speed and make the appropriate, you know, adjustments here. And then split the struct pin here and then attach them just like how I mentioned earlier. Yeah, my bad, guys. I confused y'all by confusing myself, so that's just the extra tidbit. So if y'all don't want the aiming speed, just keep your crouching as how you have it, but if you want the aim speed, you're just adding an additional node and checking if you want to aim or not. Okay, and then let me adjust these real quick. And And then lastly, get this. I'm sorry that's taking a bit, guys. I'm just trying to get these notes down for y'all to have. Just in case. Actually, I don't need to put in there because I need to move it out. So let's go ahead and move this. Move this out. Set that to group movement. And then let's get our big chungus comment in case y'all want to have this. Just moving these out of the way real quick. All right. And then I got one more comment, guys. Let's go ahead and add that into here in case y'all want it. Zoom in for y'all to be able to pause this and copy. All right, so like how we set, so we created the S gait speeds to hold, call multiple values, vector values when doing our functions, or to get our current speeds. And then based on that gait selection, we of our get desired gait function that will be passed into this, so that way we can get our appropriate speed. And then we're going to check if we're crouching. If so, we're going to get the crouch speed. And if we're aiming, then we're going to get the aim speed and pass it through here instead. Otherwise, we just go backward. And then into here, what we're essentially doing is we pass in our strafe map speed. So like I was saying, if we, depending on our direction, if we have, 0, 1, 2 from our float value that we just extracted from it earlier, we'll pass it into these and get our appropriate out range, and then pass into here and get our appropriate out range if, we meet these ranges. And then after that, if our straight map speed value is less than 1, we get the return speed values of the first clamp, else we get the second clamp values. So guys, that is pretty much it for that. We have now completed that, and we can go back into our update movement function. So let's go ahead and compile and save. Head back into update movement. Actually, go back into calculate max speed, and what we do need to do is we need to make this a pure function, because we don't want any changes made in here as we go through it, right? So because we don't need any other modifications, we just need to get currently what our speeds are. There's not much we need to do there. So go ahead and make that a pure function, and then go back out to update, and you will then see that we have a pure function. So now what we are going to do is we are going to now set our character speeds appropriately. So let's go ahead and grab our character movement, and off here you're going to grab the set max walk speed, and you're going to do it again. So I'm going to copy and paste this, and we're going to get the set crouch walk speed, or let me see, max walk speed crouched at like so. And then you're going to connect the calculate max speed into here, and then you're going to pass this into here. So basically what's going on is this will detect whether we're walking, running, sprinting, whatever, and pass in the appropriate thing into here first. So it's all the speeds will go through this, and because I know it's confusing that you'll see the crouched one right here afterwards, but it makes sense when you think about it, because if we are crouched, then this is going to be set regardless, but this only detects if we're crouched. So you don't have to worry about this being jumbled up, because if we're crouched and it detects that, then it sets this appropriately. Otherwise, if we're aiming, walking, sprinting, running, whatever, we'll be grabbing this instead. So this only works if it detects that we're crouched, because of its built-in functionality. So that's why we got the is crouched from earlier, is because that seems to tie hand in hand with this set max walk speed crouched. So now let's go ahead and grab my notes for this and paste that into here for y'all to copy. And then here, it's pretty self-explanatory, but I still wanted them in here anyway, just in case y'all wanted them. So go ahead and drag these down, and I'm going to get the big chungus text bubble and put it here for y'all to see. So let's go ahead and attach then our sequence second pin as such, just like so. And let's move it in here. So there we go, guys. We have officially set up our gait speeds based off of our current gait. So let's go ahead and compile and save and test this out. So now when we're walking, you can see that we're getting a ground speed of 300, but if I move left or right, we get 350, move left 350, backward 300. If I'm aiming, as you can see, we get 200, or we get 175, 175, 150. And then if we are walking, we get 200, 175, 175, and 50. And what you'll notice is how it lines up accordingly to our strafe map speed. That's why we added that for our UI debugging, so you can see that. And then lastly, if we are crouched, we get 200, 175, 175, 150. So there you go, guys. That's how we get our different gait speeds according to our desired gait that we set up previously. So all in all, that's pretty much it for that. And so I'm excited to call that an end. I know it was a pretty long video. I know these have been pretty long, but some exciting news for y'all is that I do have an awesome thing to show y'all with the next part. So I'm not going to be, again, not doing it in this video, but just to go over it, I have officially decoded the traversal action, and I promise you it was a nightmare. It still is a nightmare. And just to show you all context of how it looks on my side, so as you can see in here, it looks pretty tame, right? It's pretty long, pretty tame. But if we pull up my actual project of what's going on, you can see how monstrous it is, especially with the comments. On top of that, I've also discovered how these are created, or how those are done. So I actually am excited to show you all this. So what I am going to end up doing is in the coming videos with the traversal action, as we get that set up, unfortunately I don't have the animations for them. It's probably going to be a while before I get the animations, but I will end up getting you to this part right here. Step 5.1. Because as shown in here, our step 5.1 is here, and then it continues off to getting our animation instances and setting our interactions, and then doing our chooser table to get the traversal animations, and then doing our motion matching setup. So unfortunately, since this is a character blueprint series, I won't, when we finish the traversal action, I will not be going into these green comment bubbles, because these are pretty much set for animations, and I'm not ready for the animation blueprint yet. I haven't really delved deep into it, but I'm curious and I'm ready to learn more about it in, you know, a future setting of mine. But at the moment, what we're going to be going over, and these are going to be multiple videos, is the step 1, 2, 3, 4, and 5, all individually. Some of these might be multiple videos. I'm going to try to lump these comments that have like 3.1, 2, whatnot into their own videos. But if I do that, they're probably going to be very long, and I don't think y'all want to sit through them. But if y'all are willing to, that's probably what I'll do. So I'm excited, guys. I'm ready to get into that. Those are going to be horrible videos, but it's gonna be fun. It's gonna be good, because then y'all get to see how it goes. There's not gonna be a lot of testing that we do for this, unfortunately, because I have to explain individual parts. But once we get through the final video, I will then end up showing y'all how that actually looks and how our different animations are called. Because then, as you can see in here, how we do have different anim instances for playing audio when we drop, or, you know, when we land, or how we warp our character to vault and stuff like that, how we're playing the montages, stuff like that. So it's gonna be good, it's gonna be fun, I'm excited. So Other than that, guys, thank you all for watching my series. It's been a very long series so far, but I hope to see y'all in the coming videos with traversal action. So other than that, guys, y'all take care and bye.